Hello everyone. So today we are going to work on this fully physics based hovering system for this car. So this is physics simulated car body, and this red line is a line trace that I do to determine the ground level. So here what we are going to do is we are going to hover, maintain the vertical location of the car above ground on a certain level. So that's why it moves down when we get past that ledge. So yeah, so we are going to balance the car or hover the car using only forces. We are not moving by manipulating the locations through code. We are only using forces. So this is what we are going to try today. So this is more like a experiment rather than creating a realistic hover car movement. And this is the demonstration, and this is what you are going to get at the end of today. So yeah, let's see how to do this balancing, how to implement a function to determine what are the forces we need to add to balance it, and how do we calculate them. And this episode is sponsored by this generous patron. Thank you very much for your support. Alright, so this is actually the same project. I implemented the flying car in this series, but today we are going to do something new, because here let me show you. Here we are using this floating point moment component to move the car. So if I show you, it's too far. The car is working, but everything is based on floating point moment. So what I want to do is the car should move fully using physics forces. So hovering, I need to first implement hovering with physics forces and then moments. So okay, let me delete this, and let's create a blueprint class using own as the parent, pw hover car. Right, now I have this hover car mesh, and let me add, first I need to show the collisions. So it's a complex collision, but let's remove this collision and add a box collision. So a simple box. So now here I'll add this hover car, yeah, like this, and I'll make it the root. Now it's like this when I place on the word. And of course we need a camera component as well. So let's add let's add a spring arm, and attach a camera to the spring arm. I'll make the spring arm a bit longer, let's say 1000. Is it too much? 700, okay. Right, now let's process this car. Oh, this is the mesh. Right, let's process this car. So this is what we have now. Maybe let's lift it a bit. Right, now let's start implementing hovering forces. So for that, first we need to simulate physics. So let's enable physics by default. And move this up. Oh, sorry. Move the car up a bit. And let's play. Okay, so you can see it drops. So how to enable hovering? So we need to hover in a certain height from the ground. So let's add a function. Trace ground. So here what we are going to do is we are simply going to do a line trace by channel. Let's use the camera channel as the trace channel, and the start position is get actor location and end is some point below get actor location. So let's say 3000. We don't really need to have 3000, maybe just -1000. That should be enough. And if we get a hit, we can break this and to use this distance. So starting point of the trace to the hit point distance. So we can, let's add a return node. Let's return this distance. If we don't get the hit, let's return 1000. Now let's try to maintain the car at some level 1000. So I'll make this one 2000. Actually, let me split this and promote this to a variable. Promote this one to a variable. I'll call it hover height, and this one I'll use hover height multiplied by -2, so twice the hover height. We are going to trace until for twice the hover height below the car to check for ground. Okay, now I'll enable debug type for one frame. So in here, let's do a trace ground, and yeah, let's just do that and see. Okay, I could see the trace line in red. It's working. Now the next thing we want to do is, if this distance is greater than, no, greater less than hover height, we need to add some upward force. Well, adding one upward force may not be enough sometimes because the car can balance out. Car may not be balanced on one force, but anyway, let's just see. To the hover car, let's add force. Adding force might work actually. Upward only, because we need to maintain the vertical height. So let's try 100. I actually have no idea. Let's just see what happens. 100 doesn't seem like enough. Let's go for 10,000. No. Let me add a print to see if the force is applied. Let's just type force. Yeah, force is applied, but it's not moving. Okay, this one. If true force is taken as a change in acceleration instead of a physical force, mass has no effect. Okay, let's try that. Oh. Alright, so that is working, but now I think 10,000 is too much. Let's use 1,000 again and see. Why is it? I think we should be able to see the full car. And also, let's print. Here, let's print the trace distance. Okay. Oh, right. I think just 200 is enough. No need to go for. Let's try 400. So once it exceeds 400, it stops adding force, but we don't really need this kind of a moment. So it should stabilize with a minimum harmonic type of a motion. So what if should I increase this or decrease this? I think I should decrease this. Let's see. No. Yeah, actually I think we need to have something larger than the gravity force here. So what's the gravity force we have by default? 988 or 981? I think 981 or 980. Okay. So if I put 980, this wouldn't move up or down. It's balanced. Okay, so now what I have to do is this. If we are below this level, I have to add 980, something larger than 980, so 1000. Else, oh wait, we don't need a branch here. We can connect it directly and select. $1,000 or 980. Now it should balance at 400. And it's not. Yeah. Why does it keep moving up then? Oh right, here actually we should return not hover height multiplied by 2, because that's the height of the trace here. But why does it still keep moving up? It's false. That means we should be giving 980. Okay. So when we keep adding 980 and we already had some acceleration upward because we were adding 1000, so that acceleration is kept because the gravity is cancelled out by this 980. So let's add something below 980, then it should be balanced in a certain range. Let's see. Yeah, now it's moving back. But that was too much. It will be balanced in 400, but it's too slow. Okay. Okay. These values seems to work, but this may not be enough responsive for actual driving of the car, but now it kind of get stabilized in 400, so which is good. Now light can move back to 390. It moves between 390 and 405. Yeah, that's good enough actually for me. Another thing we can do is we can define like a range. So we can use in range plot. Right, so we can get this input and check if it is within the range of 400 and 450. If that is true, here, Oh, we can't do that. We have to consider the upward velocity as well. Let's just leave it like this for now. Now let's try adding some forward movement and backward movement. So basically driving the car. Before that, I need to implement camera movement. So let me just quickly copy the mouse input from the other one. Actually it's just this. I have already set up this axis, and these are not enhanced input, these are legacy inputs, but it's fine for now. Wait, it's not working. Why? Use phone control rotation. Okay. Alright. Now let's add forward and backward movements. So we have already set up move forward, what if we, instead of using move forward here, what if we get at forward vector and multiply by get move forward axis, split and connect x and y components like this. Well, I think one is not enough. It's moving, but it's very slow. And yeah, we definitely need to balance it. Too much coming back and forth, up and down. Let's add a multiplier. And let's multiply with this delta seconds as well to make it frame rate independent. Still too slow. Yeah, now it is working. But Okay. And let's hit the wall and see. Oh yeah. It's moving back. Balancing is not good enough. To properly stabilize the car, we need to consider not just the location, whether it is below or over the required height. We also need to consider upward and vertical velocity as well. So let's our car get velocity. Let me collapse this move forward part into a node. Here we can get the vertical component. Let's break this to make things simpler. This is move forward part, so let me expand this and collapse again, move forward. Right, now this one. We can actually place this before this part. Right, we don't need this one for the moment, and let's have 2 branches. Instead of large or equal, let's use nearly equal, and tolerance 20. Okay, so let's have 2 parts. Add force. Wait. Yeah. Let's add force upwards. Simply 980. And then add west component, add force, and this is same as before, add force, what did we have before? 50 and 50. Okay, and both the acceleration changes. Oh, these should be interchanged because we are choosing the nearly equal. If it is false, we should, oh no, if it is nearly equal, we have to give 980 to maintain. If it is not nearly equal, then we have to consider if it is high or low. Then I think we can add this. Let's see. Yeah, now it's not moving up and down too much, as I can see. Because earlier it was moving down like 320 also. Right. Now we need to check one more thing. Here, let's get this one and rotate, so we can check if the car is getting adjusted correctly. Well, it's not fast enough. Adjustment is not fast enough, that's why it hit. Yeah, so one more thing, we can get the difference of hover height and the distance, and then let's try this. Let's add this difference to 980. So if we are below, this would be 980 plus something, and if we are above the hover height, this would be 980 minus something. Now it's again too much of a moment to stabilize. But didn't hit. Oh, it fall on ground. Okay, now let's consider the velocity. So get the hover car, get velocity, component velocity, and we only need to consider the vertical velocity, so set component, and then if this velocity is higher than this height difference, we don't need to add force anymore. So if we subtract these two like this and connect, I think we should get a much better stabilization. Let's see now yeah, I think it's working actually, so it's not moving up and down too much. But it's much better, of course, but still it can hit the, oh, it didn't hit the ground. Nice. Okay, what if we add the multiplier? Before this step. Now the car should get adapted to the situation faster. See, it's not hitting the ground now. But we can see some rapid movement, but it gets stabilized pretty quickly. Okay. Now let's add turning. How do we add turning? By the way, it would be much easier if we just simulate hovering like movement through code without using physics, but the objective of this episode, this tutorial, is to like making it work only using physics forces. So that's why I am not trying to do anything like limiting the movement or changing the velocities through the code or anything. I only want to use forces. That's the reason. Okay, so to turn right and left, how do we rotate? In our car mesh, what if we add a socket in the front? Let's move it to a position like this, in the middle. Yeah, and let's copy that. Now for turning, move right. Let's do it here. Add force on this socket. Oh, if a skeletal mesh component, name of a body to apply. Okay, so then this is not going to work because this is a static mesh. So add force at location. Add force at location local. Okay, wait. How about radial force? Add force no, let's use this one because this is more like a exhaust force. Okay, let's use this one. And force is get factor right vector. Location is get socket location of the front socket. And of course we need to multiply it with this axis value, otherwise we will be always adding a force. let's see what happens now. Oh, once again, I don't think 1 would be enough. So we might need the multiplier. Another one for delta seconds. Get delta time, no, but delta seconds, so we can make it frame rate independent. This one, let's go for 10,000 and see. I don't see any kind of a movement. This forward is what I already applied, but left, right, nothing seems to happen. Alright, let's try this one. Some value like this, just to get a reaction. Yeah, it is working, but it's turning the car also, which is not cool. Right, so what I can think of is we might need more than 2 forces on the upward to balance the car. So like 1 force here and 1 force here and maybe another one in the middle, or at least like, or we can have like 4 forces, like 4 wheels. We might need something like that to balance. So since we have taken around 40 minutes, so I'm gonna stop this episode. Maybe in the next time let's look into how to balance it properly with turning. Right, so here is the final demonstration. I have created some simple path for us to follow. Let's go forward and see how the car gets adjusted to the ground below. Oh, it's not fast enough. So now it's over. Right. So anyway, that's all for today. And I'm gonna stop this episode right here. So this should work with something like this. And thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.